Welcome to Eureka Math. I'm Mr. Shankel. I'm going to be helping you today with Module 1, Lesson 3. Let's get started. In Lesson 3, we're talking about numbers in exponential form raised to a power themselves. So we're taking an exponent and raising it to another exponent. And when that happens, we will be able to find an easy way to write that notation. Let's look at the general case here for a second. So in this general case, right here, we can see that we have a number x that is raised to another power, so an exponent of m, and that entire expression x to the m is then raised to another exponent. So what happens is this. Let's use an example to kind of make this clear. What we're doing in the example that I've written below is 7 squared is then raised to the 6th power. So 7 squared we know means 7 times 7. So this is equal to 7 times 7. And then that is raised to the 6th power. So what that means is we're going to repeatedly multiply whatever 7 times 7 is 6 times. So we're going to have a 7 times 7 times another 7 times 7 times another 7 times 7 times another 7 times 7. And that's 4 of them, and then we're going to continue, right? This would continue down here, times another 7 times 7 times another 7 times 7. So we've got 6 of those. So all together, we're really just multiplying a bunch of 7s together. And if you'll just count them with me, you can see we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 7s that we're multiplying together. And if you'll notice here in the box, it says that x to the m power then raised to the n power is the same as x to the m times n. So what we are doing then is multiplying these two exponents together to get our final exponent. So this we could write as 7 to the 2 times 6 power, which would be 7 to the 12th. So 7 squared raised to the 6th power is the same as 7 to the 12th power. So when we see this, when we see an exponent raised to another exponent, we're going to multiply those two exponents together to get our simplified form. All right, so let's try a few of these on exercises 1 through 4. Exercise 1, I have 15 to the 3rd raised to the 9th power. So that means I'm going to have 15 to the 3 times 9 power. And we could multiply those together, but for now we'll just write it in this form so we get used to remembering that when we raise an exponent to another exponent, we multiply those exponents together. Exercise 2, I have negative 2 raised to the 5th power, and then that entire thing is raised to the 8th power. So this is going to be negative 2 raised to the 5 times 8. Negative 2 raised to the 5 times 8 would be negative 2 to the 40th power. Okay, next one, exercise 3. I have a 3.4, so my base is going to stay the same, 3.4, and I'm going to raise that to the 17 times 4. So 17 times 4 would be 68, 3.4 to the 68th power. And lastly, we have our base is an s, and s is raised to the 17th, and then that entire thing is raised to the 4th. So I have s to the 17th times 4. 17 times 4 again gives us that 68. All right, so remember, a good way to use these videos when we're using some exercises like this is, watch 1 or 2 and then pause it, see if you can solve them yourself, and then watch me and see if you get the same thing. So there's our first 4 exercises for the day. And exercise 5, let's take a look at this one. Okay, Sarah wrote 3 to the 5th power raised to the 7th power equals 3 to the 12th power, and we have to correct her mistake. Well, 3 to the 5th power raised to the 7th power, we know, would be 3 to the 5 times 7 power. 3 to the 5 times 7 power would be 3 to the 35th power. So 3 to the 12th is definitely not correct. And we have to figure out what she did wrong. Well, notice 5 plus 7. 5 plus 7 equals 12. So I think that Sarah looked at this and got a little confused about what was going on. So here's what I think Sarah did. Sarah thought that if we had 3 to the 5th power and we multiplied that by 3 to the 7th power, then we know from our last lesson, when you multiply bases that are the same with exponents, you add the exponents. So this 3 to the 5th times 3 to the 7th would be equal to 3 to the 5 plus 7, and that would be 3 to the 12th power. So an easy mistake, one that happens a lot, and we have to be careful. So notice the difference. We had 3 to the 5th raised to the 7th power. If you raise an exponent to another exponent, then you're going to multiply those exponents like we did to get the correct answer. If your exponents are multiplied together, if you have 3 to the 5th times another base with an exponent, then you add those exponents to get the correct answer. Okay, so got to keep those straight. Practicing with these type of problems will help a lot to remember when to do what. So make sure you're doing those IXL exercises when they're assigned to you. Okay, next. For any numbers x and y and a positive integer n, we have this x times y raised to the nth power is equal to x to the nth times y to the nth. And the reason that happens is, notice here, if you have x times y to the nth power, it really means that you're repeatedly multiplying x times y, and you're going to do that n number of times. So let me give you an example here. If we had, let's say we have 5 times 2 to the 3rd power, okay, 5 times 2 to the 3rd power. What that means is we're going to repeatedly multiply the base, which is 5 times 2, 3 of them. So I'm going to put 5 times 2 again, and then another 5 times 2. So all of these are multiplied together. And then notice what we get here. We've got 3 different 5s that are multiplied together. That can be written as 5 to the 3rd power. And then we're going to multiply 3 2's together. So that would be 2 being repeatedly multiplied, and there are 3 of those. So we get what we're told that we're supposed to get, and that is the base raised to the 3rd power, 5, that base raised to the 3rd power, and then the other base, 2, also raised to the 3rd power. So 5 to the 3rd times 2 to the 3rd, and remember that would be equal to equivalent to this 5 times 2 raised to the 3rd power. Okay, so we would be able to take that information and answer the following exercises. So let's look at these. So knowing I have an expression here, 11 times 4, and that entire expression is raised to the 9th power, I can say that I have 11, the first base, raised to the 1 times 9. Now, I use the 1 because 11 to the first power is the same as 11. So we have 11 to the 1 times 9, and then times 4 to the 1 times 9. So there's the first one, exercise 7. Exercise 8, I have 3 squared times 3 to the second power times the fifth power, because this 5 is raising the 3 squared to the fifth power. And so I have 3 to the 2 times 5 times 7 to the 4 times 5. Right? We're raising an exponent to another exponent, so we multiply those exponents. Okay, here we have, on exercise 9, we have 3 squared to the times 5, so 3 to the 2 times 5 power, and then a to the 4 times 5 power. And those would be multiplied together. I don't need that multiplication symbol there because it's a variable. All right, let's do a few more. Exercise 10, we have 5 to the 1 times 7 times x to the 1 times 7. Exercise 11, we have a 5 to the 1 times 7 times x to the 1 times 7 times y to the 2 times 7. Okay, so the little bit different there. Exponent of the 5 is really a 1. We just don't show it. Exponent of the x is also a 1. We don't show it. The exponent of the y is a 2, so it's a little different than the first two, so we have to use that. That's 2 times 7. That's how we get this here. All right, and then the last one, all variables. We have a to the 2 times 4, 2 times 4, and then we have a b to the 1 times 4, and then we have a c to the 3 times 4. So there we can show that we are multiplying our exponents. All right, very good. Moving on. Let x and y be numbers. Y is not 0. And again, y is not 0 because we can't have a y as our denominator. That's undefined. And n is going to be a positive number. So our integer is, our exponent is a positive integer. And we're going to show how that x over y to the nth power is related to x to the n and y to the n. Okay, so here's what this really means. What we're saying is we're taking this x over y and we're going to repeatedly multiply that by itself, x over y, and we're going to do that n number of times. So all of this is going to happen n times. That's the exponent. It tells us how many bases to multiply together. So that's what's actually happening. So if we look at that another way, we could say that all of these x's, if I had an x over y times another x over y times x's over y's, all of those things are happening on both sides of the fraction bar. So if I say that x itself, the numerator x, is being multiplied n number of times, then the y is also being multiplied. The denominator is also being multiplied n times. And so that we could say that the x is multiplied together n number of times, and the y is multiplied together n number of times. So we have x to the n over y to the n, and that is equivalent to this x over y raised to the nth power. So these two are the same, and you can see how they relate to each other, and they are equivalent to each other. Okay, that is lesson 6. I hope that helps. I'll see you again next time. Sorry, not lesson 6. That is lesson 3. Lesson 3. I hope that helps you. See you next time.